Hey class, so I'm going to talk about this idea called a view volume. And it's something you'll come across a lot in 3D if you work in 3D. Basically, our projection that we set up, it defines a region within which we can see things. So our projection define regions in the coordinate system maybe defined by our view, for example, if we're using the camera model, where things are visible. So we have this region where things are visible. It can be useful to visualize this, and so this is what a view volume is. It's basically a visualization. Great, so it can be useful to visualize this. So I'll start with a top-down visualization. So this is my eye again, and this is my raster. So you can imagine that we see the raster, but if I'm in, actually I should have labeled this first. Let's move it down. If I'm in orthographic, well, that's interesting. It lost my color when I copied pasted. Oh well. If I'm in orthographic, then once I hit the raster, I have these parallel lines here off to infinity, defining the region that I can see, right? And then if I have perspective projection, it looks a little different. I have my eye here still. I have my raster where the image gets projected, but in perspective, it just keeps going, right? So I have these, they come out at an angle, and anything within that region I can see. Now these are infinite regions, but what we end up doing is if we add a near and far distance or bounds, and there's several reasons for this, but basically the biggest one is infinity doesn't go well with computers. Computers have limits too, right? So we can't draw forever. So we say, look, I'm going to draw within this region of Z to cap that from not being forever. So if I add a near and a far bounds, then we get a view volume. That defines everything I can see. So let's see what that might look like. So first of all, imagine I have an eye down here, and this is orthographic again. I did not give myself enough room. Imagine I have an eye down here. Okay, so I imagine that the view volume that I can see looks something like this. This is what I can see. This is my 2D raster scene. Now, oops. This is my, I should change color. This is my right. This is my left. This is my bottom. This is my top. Okay, and this is my near point. And then I imagine I have this far. So I can fill this in and envision that I actually have this volume, this rectangular prism, basically, that defines everything I can see. This is my view volume for orthographic projection. This box, everyone calls it the box, it's actually let's see if I can get this right, rectangular parallel pipe head. Okay, defines everything inside that box we can see, outside that box we can't see. For perspective, it's a little trickier. In fact, I'm probably going to mess this up as I'm trying to draw it. So imagine you have your raster here. But now if I draw this point, up this way, the far clipping point is going to be bigger because it's further away, right? Yeah, let's try fixing that. Yeah, I told you I'm gonna mess this up. An artist, I am not. Okay. Okay, so bottom right corner. Perfect. That's what I want. Like that. And you can imagine now, I have this funny shaped region within which I can see this view volume. It's like a cone. It goes out like this. It kind of goes, you know, it actually, if you want to exaggerate it, it kind of goes out. Yeah, I did that wrong again. See, I cannot draw myself these shapes. Right? You get this exaggerated shape. And if you look at it, it's actually a pyramid with the top cut off. And if I cut off the top, I get this 3D shape left. So with perspective, now that I've beaten that to death, with perspective, because it gets wider and wider the further you go, you get this really funny looking shape. This is my near, this is my far, and left and right, top and bottom, right? But this shape is called a frustum. This is called my view frustum. It's a shape, it's like a pyramid with the top cut off. It just gets bigger, the bigger, and as you go further away. It's not straight like the orthographic projection. So this is what our view volumes look like. And this is actually very useful for a couple of reasons. One, if we can determine beforehand if our object is not within the view volume, we don't have to draw it. We can call it. And I'm going to come back to that in a few lectures. We'll talk about calling a bit more. Don't draw. It's also, people find this very useful to visualize and understand what a projection will look like. Okay. So when people talk about or you read about the view volume, that's all that this means. This 3D space, the box or the frustum within which you can see. Outside of that, you know, if I add some objects in blue here, you know, I'm gonna add some alphas. You can't see that fish. You can't see that one. It's up here. You can't see that one. Or this one's in your view, but it's behind that plane. You can't see it. You can't see any of these things outside. Okay? So the objects can be in your scene, but they're not in the view volume. You can't see them. Okay? That's it for today. Thanks.